Assalamu alaikum. Today we will discuss the differentiation of some inverse trigonometric functions. So for that, functions. So for that, let's choose this very function. Differentiation of sine inverse x. We need to prove it. This is 1 divided by under root of 1 minus x square. We know the graph of y equal to sine of x. So let me draw roughly the graph of sine inverse of x. So this is like sinusoidal like this one, right? It is 1 and its minimum value is minus 1. But in fact this function sine of x, this is not an invertible function over R, so we need to restrict its domain. So it's invertible. We know that its principal argument, it lies between minus pi by 2 and pi by 2. I mean this very function. So I'm actually using its principal argument, that's minus pi by 2 and 2 pi by 2, right? So that it is invertible, and I can find its inverse and take the differentiation of its invertible inverse function. Okay, let's choose the function, say y is equal to sine inverse of x. We need to differentiate this function, right? So before differentiating by Initio method, what we do is we will make it simpler. We will make it in terms of sine. Actually, we know sine and sine inverse, they are invertible functions, right, of each other. So I can write actually x is equal to sine of y, right? So if I'm assuming if delta of y is increment in y, is increment in y. Look here, actually the argument of sine is y, so I need the argument to be in this interval. So if the increment, if del y is increment in y, and let's suppose del x is corresponding increment of x, is corresponding increment in x, so I can write it. This is x plus delta of x. This is sine of y plus delta of y. Say name it this very equation first and this very equation second. We can subtract equation first and second, subtracting first from second. We get, so it is actually x plus delta of x minus x. So x and x will cancel, so this is delta of x is equal to, now this is like sine of y plus delta of y minus sine of y. So obviously if we look at this one, it is similar like this formula, sine of a minus sine of b, right? So this is actually, this is twice cos of a plus b by 2. So addition of the average of the angles, right, into sine of a minus b by 2. So what I can write here, this is twice, I can write here cos of, take the addition of these two angles. One angle is this and another angle is y. So this is actually 2y plus del y. This is 2y plus del y divided by 2, right, into sine of, take the difference. Now when we take y plus del y minus y, so y cancels, this is del y by 2, right? Now on both sides, what we can do, we can take the increments on both sides of this equation. Now what increment would be good? So let's divide both sides by del y. So what we do is, actually this is del, oh sorry, not this one, but wait a second. So let me write it first. So this is delta of x divided by delta of y. This is okay. So let me write it here, twice cos of 2y plus delta y divided by 2 into sine of delta y by 2 whole divided by, is delta of y, right? Now, in fact, what we can do is that we can use this 2 here, this 2 here. So let me erase 2 in the numerator. Let's take it here, 2, right? So I can also write it as cos of 2y plus delta y divided by 2 into, now this is sine of delta y by 2 whole divided by delta y by 2, right? Now taking limits, I can here use taking limits delta y tends to 0 on both sides. What we get is limit delta y tends to 0. This is del x divided by delta y. This is here. Now see here, two functions are in product, this and this function. These are in product. So I can separately take limits to both. So I take limit, delta y tends to 0 cos of 2y plus delta y divided by 2 into limit. Now see here, delta y tends to 0, sine of delta y by 2 divided by delta y by 2. Actually, whenever, I will use the fact here that is delta y tends to 0, it means delta y by 2 also tends to 0. Its half will also tend to 0. So it's better to take delta y by 2 tends to 0. Now, this very limit, it is not new thing, but it is like its limit like theta tends to 0 sine theta divided by theta. So theta is here, theta is here, theta is here. So this we know that this is the standard limit, it is 1. Second thing, I will use here the standard definition of the differentiation. That's in this one. I can replace it d. This del variation can be replaced with. So this is dx by dy. So what is dx by dy actually here? Now one more important thing. Delta y tends to 0. It is operating over whole this function, but I am giving delta y only to this. So it means that it is bypassing this cos, right? I can bypass this cross. Why I can bypass it? That is an important question, right? But here I will bypass it for some point, for some time. So when delta y tends to 0, this is 0. So this would be 2y divided by 2. 2 and 2 will cancel. So only thing what will remain is y. So this is actually cos of y into 1. 1 is the limit of this thing, right? This whole is 1 actually, right? Now this is actually cos of y. Now it means that if this is cos of y, this also means that if I can take the reciprocal of this equation, what would that mean? What would that mean? The reciprocal of this equation also means that dy by d of x is equal to 1 divided by cos of y. But you know what? Sine theta, or I may say sine y, sine square y plus cos square y is equal to 1. It means that cos square of y is equal to 1 divided by, sine square of, sorry. So I can write cos square of y is equal to 1 minus sine square of y. So I can write it cos of y is equal to root of 1 minus sine square of y. So I can replace this as 1 divided by the root of 1 minus sine square of y. But why I'm taking only here I have actually plus minus. I'm taking only positive sign. Why I'm taking positive sign? Note that also. Okay, now I can replace, whenever we have taken y is equal to sine inverse of x, it means x was actually sine of y. So x square would be sine square y. So it means that this would be 1 divided by under root of 1 minus sine square of y, but sine square of y would be x square. So this is x square. So what we have learned from this is the following. We have learned that, wait a second, we have learned from this following, that is dy by, sorry, what we have learned from this is the following. We have learned d by dx of, sine inverse of x. This is 1 divided by under root of 1 minus x square. Simply by ab initio we have used it, right? Similarly, we can do it for the others like cos inverse of x, tan inverse of x, right? Thank you for today.